All right, let's just dive right into this explainer. If you've ever stared at a massive string of numbers being multiplied together and thought, man, there has got to be a faster way to write this down, well, you are absolutely right. Today, we are unlocking a literal mathematical superpower, exponents. We're going to break down exactly how they work, why they save us so much time and space, and how you can master them without breaking a sweat. We've got a lot of ground to cover today. We'll start by decoding the exponent shortcut, then look at the exact steps to use them. After that, we'll walk through some real examples in action, point out a few common mistakes to avoid, and finally, put your new skills to the test with some practice. So, kicking things off with part 1, decoding the exponent shortcut. What exactly is an exponent anyway? Simply put, exponents are just a shorthand way to write out a number that is being multiplied by itself over and over again. It's basically a mathematical abbreviation. So instead of writing the same number all the way across your page, an exponent steps in and neatly packs all that data into one highly efficient little package. You can see the difference right here. Look at an expanded expression like 3 times 3 times 3. It just takes up way too much space. I mean, imagine if you had 20 threes. That would take up an entire line. But in exponential form, we just write the base number, 3, and raise it to the exponent, 3. That little raised number is the exponent, or the power, and it literally just tells us exactly how many times to multiply that base number by itself. Now, what's kind of cool here is that we actually have special names for a couple of specific exponents. When a base, like 6, has an exponent of 2, we often say 6 squared. And why is that? Well, it ties perfectly to finding the area of a physical square, which is just length times width. And since a square's sides are all equal, you're always multiplying a number by itself. Same thing goes for an exponent of 3. We call 4 to the third power 4 cubed, because it directly relates to finding the volume of a 3D cube, length times width times height. Moving right along to our blueprint for success, the actual steps to use exponents. Whenever you need to rewrite an expanded expression into its exponential form, just follow these 3 super reliable steps. First up, identify the base, or bases. Like, what is the actual number being multiplied? Second, carefully count how many times that base is being multiplied by itself. And third, just rewrite the whole thing. Put the base at the bottom and your count up top as that small exponent. It's simple, it's structured, and it works every single time. But what if you're asked to go the other way and actually solve an equation with exponents? Well, you essentially just run that blueprint in reverse. First, change the equation from its compact exponential form back into its fully expanded form. Writing it all out lets you clearly see the math right in front of you. Then you just do the multiplication to calculate the final number. Honestly, expanding it first is a total lifesaver. It stops you from taking weird mental shortcuts that usually lead to mistakes. Okay, let's head into the training ground. It's time to walk through some real examples in action. Here is our first challenge, 11 times 11 times 11 times 11. Take a quick second. How would you write this out using our 3-step rule? What's your base and what's your count? Nailed it! The base, the number actually being multiplied, is 11. And counting them up, we've got 4 of them. So our exponent is 4, making our final answer 11 to the 4th power. Just look at how much cleaner that looks compared to a giant string of 11s. All right, let's kick it up a notch. What happens if we mix different numbers into the exact same expression? Take a look at this one. 3 times 3 times 2 times 3 times 3 times 3. Kind of a mess, right? How do we clean this up? You just do the exact same steps, but apply them to the different bases individually. So here our bases are 3 and 2. If we carefully count the 3s, there are 5 of them, giving us 3 to the 5th power, and that poor little 2 is only there once, so it doesn't even need an exponent written out. It just naturally tags along at the end. So our neat, cleaned up answer is 3 to the 5th power times 2. Okay, let's switch gears from rewriting to solving. We've got 6 to the 4th power here. Take a second and think about our 2-step rule for solving these. What does 6 to the 4th power actually equal? To solve this safely, we expand it completely first. 6 times 6 times 6 times 6. Now just deliberately walk through the math. 6 times 6 is 36. Multiply that 36 by 6 to get 216. And then multiply that by 6 one last time, and our answer absolutely explodes in size to 1,296. It really goes to show just how crazy fast exponents scale numbers up. And for our toughest training example today, fractions. We have 2/3 trapped inside parentheses raised to the 5th power. Those parentheses are incredibly important, by the way. Any idea how we expand this one? So the parentheses are basically telling us, hey, apply this exponent to the entire fraction, both the numerator on top and the denominator on the bottom. We expand it by multiplying 2/3 by itself 5 total times. Let's take it slow. Across the top, 2 multiplied by itself 5 times is 32. Across the bottom, 3 multiplied 5 times gives us 243. So our final answer is 32 over 243. Now, math can be tricky, so let's put up some guardrails. Here are the most common exponent mistakes you really need to avoid. The absolute biggest rule: never ever just multiply the base by the exponent. The exponent tells you how many times to multiply the base by itself, not by the exponent. Second, be super careful not to miscount, especially when you have long expressions with mixed bases. And third, don't forget about the invisible exponent of 1. Let's actually talk about that invisible one for a second, because it trips up a lot of people. Literally every single number in existence, whether it's a solid 8, a fraction like 1/8, or a decimal like 1.8, is technically itself to the power of 1. Even if it's not explicitly written there on the page, it's always hiding behind the scenes. 8 is the exact same thing as 8 to the 1st power. Do not forget it's there. All right, time for a quick pop quiz. Let's practice your new skills and put this exponent knowledge to the test. Here's your question. Solve 5 squared. Think fast and remember those common traps we just talked about. Is it 10, 25, 15, or 32? Lock in your answer. Fantastic! If you picked 25, you absolutely nailed it. The answer is 25, because we expand the expression out to multiply the base, 5, by itself, 5 times 5. You successfully avoided the ultimate rookie mistake, which is multiplying the base of 5 by the exponent of 2 to get 10. You didn't fall for it. As we wrap up this explainer, I really want to leave you with this thought. We saw earlier how 6 to the 4th power jumps straight over 1,000. Imagine graphing these numbers as the exponents get larger and larger, say to the 10th or the 100th power. Ask yourself, just how fast can exponential growth truly explode? It's a concept that dictates literally everything, from the computer processing power in your phone to the growth of global populations. And now, you've got the mathematical tools to understand exactly how it works.